just so we get lots of different or different opportunities to work on different examples. And I put up a homework just so everybody can see this, not there. Under this one, under assignments, I put up a single sample t-test.
Okay.
Yeah, and so I'll open it up here just so you guys can look at it. And let's see, eventually it'll pop up. There we go. So it's an example of a single sample t-test, okay? And here's all of our data. And don't worry, right now, this probably looks confusing if you didn't see yesterday's video. We will go over today the 4 steps, okay? And so we will learn how to do this, all right? So just so you guys know, it is there. For anybody looking, our 10 students, so that would be our N, is our sample size is 10, okay? And then here it's saying that the average number of hours, a typical college student, so we would use 7 as our population mean, okay? You will need to calculate your sample mean by getting the average or the mean of our sample. Okay, so yeah, so just in case, if you're looking that over and don't understand where those numbers are coming from, okay, I will work it out. I don't think I have on me the answers right now, but I'll work it out. So if anybody is working on it and you get stuck and you want to email me, go ahead and do that, and I can answer back any questions or see what problems are coming up when you guys try that, okay? All right, so let's go through, I was typing a problem there so I wouldn't have to do it once we had class. So let's start real quick going over these slides and kind of stating again what we talked about last week, just a little bit about the t-distribution, and then we'll move on to performing a t-test, okay? So again, the t-distribution is used when we do not know all of the population data, or here it says parameters, right? Parameters refer to a population. So when we do not know the population standard deviation, we're going to use a t-test, okay? Here, I didn't mention this yesterday, but it's also if you're comparing 1 or 2 samples, okay? If you know all the data of the population, then you could certainly compare 1 sample to the national or known population, and you could do a z-test there. But if you don't know all of the information about the population, and you have 1 sample, you can perform a single sample t-test, and that's what we'll be going over today. If you have 2 samples, we would call those a 2 sample t-test. Of course, then that calls for a t-test, and there's 2 different ones there, and we'll talk about that next week. We don't need to worry about that today. So let's get down the single sample t-test, and then we'll discuss 2 sample t-tests later. Okay, this is just showing again pretty much the central limit theorem. When we have an increase in our sample size, our distribution approaches a normal curve. Okay, and if you remember from chapter 8, I showed on a t-test when you have an infinite number of participants or a very large sample size, then actually the t-distribution becomes a z-distribution, or a t-distribution becomes a normal distribution. So that's all that this is showing here, okay? That as sample size increases, our distribution looks more like a normal curve, okay? All right, just to go over a little bit again about the z-table and how we work this data here and how we find these numbers, okay? One thing is you have to know degrees of freedom, okay, which is right here. Maybe I should get up my draw. Degrees of freedom is this column here, Okay, and this is how we will find the critical values. Okay, so you have to look at degrees of freedom. Degrees of freedom for our purposes is n-1. Okay, so whatever your sample size is, subtract 1, and that's your degrees of freedom. Okay, so if I told you our sample size is 10, then our degrees of freedom would be 10 minus 1, and therefore it would be 9, right here. Okay, and we would use this row. Sorry, that doesn't really look like an arrow right there. We would use 9, and we would use that row. Now, convention, or just the way it is in social sciences, we use the 0.05 alpha level. Okay, we set our probability at 5%, that we want to know we have a less than 5% chance of making a false positive. Okay, so we set our alpha at 0.05, and it's more conservative to do a two-tailed test. Okay, and compared to, as you can see up here, this is a one-tailed and this one is a two-tailed. Okay, and we usually go with 0.05. So what that means for you guys is when you're looking at this table, you will always look over here in the degrees of freedom, but you can pretty much say you're always going to be working in this column right here. Okay, we're always going to be working in that column right there. Yesterday, we had a question about, would we ever use any other alpha levels? Yes, right. If you are going on to UTEP and you're going to go into general experimental, they might want to mix it up on you a little bit. They might tell you use a two-tailed at the 0.01. Okay, that means you would look here and the two-tailed and the 0.01, and that would be this column here. Okay, they might tell you do a one-tailed at the 0.05. Here's one-tailed, 0.05, so it'd be this column. Okay, that's only if they tell you and they make that recommendation, or they say we want to test it at this level. That's when you would work that table and you would use the different columns. If they do not say anything, if it just says do a hypothesis test, then we know, okay, what we're going to do is the two-tailed 0.05. Okay, that's just the kind of the default. Okay. All right. Any questions over that part? I know I only have a few people here, but just in case. Just in case. No? Oh, hello, Cassandra. How are you?
Good. How are you?
Doing well? Good, good. I'm happy I got my camera on. I finally got my camera working. Okay, so all right, so we're good there so far. And again, I'm going to explain all of this and what it is that we're doing exactly. Okay. My puppy came in and then they closed the door on him, and now he said he's inside. So let me let him out real quick. You'll close it after he walks out. Okay, thank you, baby. All right, sorry, guys. He's like a typical kid. He wants in and out, in and out. Okay, so let's put, since this is just what it is, and I think when we go through an example right here, we're going to see, and it'll make more sense. Okay, so I'm going to minimize myself here real quick, just so I don't have to watch myself. Okay, the single sample t-test. Okay, the single sample t-test, well, all of our, not just the single sample t-test, all of our hypothesis testing is going to have 4 steps. Okay, some textbooks that you might run into in the future might have 7 steps, and anywhere between 4 and 7 is kind of typically what I see. It just varies. It just depends. It'll depend on your professor at the time, what they want you to do. Okay. I do the 4 steps because I think it's enough and it works, and it gets the basics down. Some of the other stuff is just a little tedious and maybe not exactly necessary. Okay, baby. Okay. All right. Hold on just a minute, guys, real quick. Sorry, guys, we had family in, and so my niece is leaving. Okay, so yeah, I think the 4 steps is enough. Okay, so let's see. So the first step is going to be stating our hypotheses. Okay, whenever we state our hypotheses, we're going to want to do both of them. All right, so that's why it's plural there. Okay, we're going to state the null hypothesis, and we're going to state our alternative hypothesis or our research hypothesis. Okay, step 2 is identify the critical values. Okay, we'll go over that right now. Step 3 is the big step. This is the step that takes the most time, it has the most effort, the most work that we have to do. And this is where we do all of our calculations. Okay, this is the math step. And then the last step is make a decision. If you remember from last week, we discussed that we were either going to reject the null hypothesis or we were going to accept or fail to reject the null hypothesis. Okay, so we're going to have to do one of those. All of these steps are necessary in ultimately deciding whether you have evidence to support your alternative hypothesis or you don't have enough evidence and we are going to have to stick with the null hypothesis at that time. Okay, so this is how we determine whether we have statistical significance in whatever it is that we are researching. Okay, so I will show you all of these steps. These are what we're going to be working out. Okay, so everybody take a deep breath. Here come our formulas. Okay, take a look here. I'm gonna make this a little bit bigger. Okay, so in a single sample t-test, we have about 3 steps, although I don't know if that's necessarily correct to say, but we definitely have 3 formulas. Okay, so this is our T, okay, our t-test, and this is where we're going to get our t-value. Okay, so our t-value, sometimes people call it a t-obtained, like we obtain our t-score. Okay, this, if you remember, let me see, maybe I should write it, is our sample mean. Okay, this is our population mean. And this right here, you may remember when I was rambling on about the central limit theorem and sample size and things like that, I introduced at the very end something that we call standard error. Okay, so that's the symbol for standard error. Okay, we find standard error, which is right here. Okay, also, we calculate standard error by looking at our estimated standard deviation. Oops. Estimated standard deviation, okay? And we're going to divide it by the square root of our n right there. Sorry, that looks like a z or something. I didn't want to do that. Okay. So we're going to take our estimated standard deviation. We're going to divide it by the square root of n. Estimated standard deviation is also right here. Okay. Way back in chapter 4, we learned how to calculate those 3 main ways of variability, right? We had our range, our standard deviation, and variance, okay? Within standard deviation, I believe I mentioned estimated standard deviation, okay? We didn't practice it in that chapter, but it's essentially the same thing that you were doing. The only difference is this denominator right here, okay? You all learned with only n, okay? You didn't have this n minus 1 right here. This is how you learned that formula, okay? When we do a t-test, we don't know the population standard deviation. So we're going to have to estimate it. We're going to have to guess just a little bit, okay? And we do n minus 1 so that it makes that value just a little bit bigger, something that we could assume would represent the entire population, okay? So estimated standard deviation is the formula we're used to, just in that denominator is n minus 1, okay? All right. So these are our formulas. Does anyone have any questions just right off the bat about those formulas? Some sort of symbol in there or something along those lines? Let's see, I'll put you guys up again. We doing okay on that? Okay, we're good. All right. Okay, so let's move on and now finally put this all into practice so that we can see exactly what it is that we're doing, okay? So here I listed an example for us. So this is a single sample t-test. And let's see what the words are here. Okay, here's our little problem. So it says, the standard recommendation of sleep is 8 hours. Researchers were interested in the effect of regular daily exercise on the sleep. Probably should just say on sleep, right? The following data was collected from 8 participants. That's a big thing right there, okay? From 8 participants who report regular daily exercise. Below is their average sleep reported for 3 months. Okay, so, you know, I try not to have too many numbers in a problem like this. You know, it's not like a STAR test from high school where you have to sit there and kind of weed out what's important and what's not important. But I guess ultimately that, you know, that's going to come up sometimes. Okay. So the recommendation of sleep is 8 hours. All right. This is a big one right here because this is what we're going to use as our population mean. Okay. This one is going to be our population mean. The way you know that population mean is given to you is it's going to be some sort of kind of grand statement. It may easily say the national average is, okay, and it might tell you 8 hours. It might say the population mean is 8 hours. In the example yesterday, we were using the Snickers bars and the claim that a Snickers bar should weigh 58.7 grams. Okay, that's like a company claim. Whenever you hear a company claim, that's also going to be your population average. Okay, so the hardest, well, I mean, maybe the hardest part of that is sometimes finding or weeding out what is exactly the population average that they're trying to give us, okay? And then here, 8 participants, that's going to be our sample size, okay? Our N is going to be 8, okay? Now, they're not always people, right? Like yesterday, the problem was he went and bought 6 different Snickers bars and weighed them all, okay? So he had 6 Snickers bars, so N was 6, okay? And the sample was Snickers bars, it wasn't people, okay? In this one, the 3 months, that's pointless. We don't need to know that, okay? That doesn't do anything for us. Okay, so I think we're ready now to start our data and what we need to do with our hypotheses and our hypothesis testing. So let me get back to my typing, and I'm going to put in a little text box over here, although, oops, I think I was already in a text box now that I think about it. Yeah, I am. No, stop. Though if I start typing, it's going to get all weird, huh? So I'll just do it. Oh my gosh. Why is it doing that? Oh, here we go. Okay. Finally. I'm going to put the outline on it too, just so I can see it. Okay. All right. So step 1 is to state the hypotheses, okay? So what we're going to do is we're always going to state the null hypothesis and the research hypothesis, okay? I'm just going to put, well, I'll do it right. I'll do it like I'm supposed to. H0, remember it looks like ho, okay? But it really is just H0 for the null. All right, now the null hypothesis, remember null meaning 0, zip, zilch, nada. He says that there is going to be no difference, okay? So if you want to start out stating there will, be no difference, right now let's just say among the means, okay? If you wrote that, for me, I would be okay with it. I would give you credit for it, but I'm going to push you and I'm going to write off to the side, or I'll send you a little note and say, let's do more. Okay, let's push this a little bit further. All right. And so I like to start it off with just there will be no difference among the means. And then from there, we can expand and we can add detail. Okay, so we know the null states there's going to be no difference. Okay, among the means. Okay, so of what, right? Mean what? What's the mean? What are we looking at? We're looking at sleep, right? The number of sleep. Okay, so we could say among the means, or among the mean number of sleep hours. I don't know. Oops, not spelled like that. Of sleep hours, or hours of sleep, however you want to say it. Okay, the mean number of sleep hours. Okay. What are the two groups? Who are we comparing? Right? If we're going to say that there's no difference among the mean number of sleep hours, among who? We're looking at a sample of 8 participants, right? And we know these are people who report regular daily exercise. And in this example, it's a little bit hard to find the other group, but it's just like the population. Okay, we could say just the population average, or we could just say, you know, even compared to regular adults, or it really doesn't matter what you say. So this is what kind of makes it hard for some people, is there's a lot of variability at this point, right? You can really word this in a number of ways. You might be looking at mine and going, God, I would never say it that way. Great, don't. Say it your own way. So there will be no difference among the mean number of sleep hours between the sample participants and the, I don't know, we'll just say adult population, I guess. I don't really know. Adult population. It doesn't say we're looking at adults, but I know we don't recommend 8 hours for children. So there will be no difference among the mean number of sleep hours between the sample participants and the adult population. I don't know. We're looking over it now. I'm like, it's kind of wordy. I might change it a little bit. But I think it states we know what we're looking at, right? And so that's the big thing. When you're writing this for me or any other professor, the more detail that you put in there is going to show that you know who you're comparing and what you're comparing, right? We are comparing the 8 participants to the regular population, and we are comparing the number of sleep hours. Okay, you could get even more wordy than me and clarify with the sample participants, because we know what's separating them from the population is their regular daily exercise. Okay, so you could get even more detailed than that. This part, some people really like it. They're really good at stating their hypotheses. Some people don't like this part. They don't like the words. They would rather just get straight to the math. Okay, and that's okay. So it just takes practice. Okay. All right. So our alternative hypothesis is indicated again here by H1. Okay, and our research hypothesis obviously states that that there is going to be a difference, right? I mean, that's why they're doing the research. They think that exercise is going to have some effect on sleep. Okay, now, well, let's just get through it, and then I'll talk about what my thought process was real quick. So let's see. We'll just start it off. There will be a difference between, I'm going to do it a little bit different this time just to show you, between regular exercise. Oops. I always say if I could spell, it'd make my life so much easier. Exercise. Oops, what am I doing? On mean sleep hours. Let's see, there will be a difference between regular exercise on mean sleep hours compared to the national average. Or, well, it's not even an average, right? Compared to the national recommendation. Maybe even between isn't good. Like once you go back, you could look at it and say, maybe between doesn't really make sense, but there will be a difference among regular exercise. Yeah, that doesn't make sense. On mean sleep hours compared to the national recommendation. You could even say something like, there will be a difference in mean sleep between the 8 participants and 8 hours. I mean, you could even just mention the 8 hours, that the mean number of sleep for the 8 participants will not equal 8 hours. You could do something very simple like that as well. So lots of different ways to word this, okay? I always say there's a lot of right answers and there's a few wrong ways, obviously, right? If you just don't know what you're comparing. But we'll look at that, okay? Now, what I was going to say is, obviously looking at this, and you can assume that the researchers are going to say that exercise is going to increase or have a positive effect on sleep. And so that they're probably going to say the more you exercise, the more you will sleep. Okay. When you imply that there is going to be your sample mean is going to be greater than or less than the national average, then that's where you start to get into what would be a one-tailed or a two-tailed. Okay, if I believe that my sample mean is going to be greater than the average, then that means that I believe my numbers will be in the positive end of the distribution. Okay, if I believe that my sample mean will be less than the national average, then I would expect my t-value to be in the negative end of the distribution. And in that way, that's when you look at only one tail or the other. Okay, when we do a two-tailed, excuse me, in statistics or in social sciences, it's that we're trying to say, well, one, it's more conservative because it's harder. It's you're, instead of doing all 5% on one end of the distribution, we're dividing up that critical 5% on one end or the other. So we're not implying that we're going to know which way it's going to turn out. We might have a feeling, right? We feel like this is going to increase their sleep, but we're going to stay conservative. We're going to say it could go either way. Okay, maybe people who exercise don't need as much sleep. Maybe they have more endorphins. Maybe they have more serotonin. Maybe they're happier. Maybe they don't sleep as much. Okay, so we don't know. So we're going to leave it as a two-tailed. Okay, and that's why we get a very kind of generic hypotheses. Okay, we're not implying, we're not trying to claim that it's going to be higher or lower. Okay, so some people don't necessarily like that when it's like kind of vague like that, but that's why we do that. Okay, so we just say something kind of generic that there is going to be we expect we're going to find a difference. Okay, I'm sorry. I don't know if I ramble on that stuff. I try not to. I want to make it where you all understand